is basically what we're doing at Auburn. And we've got a pretty good multidisciplinary team. A little bit about my background. I worked at Mississippi State University over in East Mississippi as the aquaculture specialist for that particular area. Worked over in the Delta area for a while, working primarily with the catfish industry, and now at Auburn, been there for about 8 years. Actually, it'll be 10 years in January. And coming into this, coming from Mississippi State, where it was primarily aquaculture, coming into the Auburn area, where we cover a whole different gamut, a whole broad area of fish disease work. And we've got a really good multidisciplinary team that we work with. We've got basically 5 people that work in the fish health area on the main campus. And we've got Ash Buller here. He's primarily a marine parasitologist. He's done a lot of work in, on the Gulf Coast, especially did some work with when the oil spill happened from the Deep Horizon spill a couple of years ago. Eric Piedman, who's an immunologist and geneticist, where he's looking at different genetic lines of fish, both from an aquaculture standpoint as well as conservation, threatened, endangered, sport fish population, trying to find specific markers, but also how some of those things and traits and characteristics may influence disease issues. Dr. Kova Arias, she's a molecular biologist, spends a lot of time looking at molecular traits of pathogens. And then Yolanda Brady, who is a shellfish parasitologist, disease specialist. And then myself, I'm more of an epidemiologist. And so I get into the area of applied fish health research, and I'll go through some of all of these areas here in just a second as we go through this. But coming up on 48 years now, since 1964, we have at Auburn what's called the Southeastern Cooperative Fish Disease Project. And basically this project was started under Dr. Homer Swingle. And most of you who have been through any kind of fish pond management probably have heard of Dr. Swingle. He's the father of modern day fish biology. And he started this whenever he started seeing the onset of new aquaculture commercial industries happening, as well as state hatcheries DNR work as they started coming online. So as the fish culture started getting more intensive, we started seeing more and more disease problems crop up. And so he felt it was important to start establishing a unit, which at the time was kind of the first in the country, at least in the southeast area, to help address some of the problems that are associated with fish health management and disease work. And so within this cooperative disease project, we have contributing conservation agency, DNR agencies, that help contribute money into the program. And we provide back basically 3 different areas or objectives within this project. The first of this is diagnostic services. And I'll be going through some of these things here in just a minute and just expand upon them a little bit. Then we provide also an educational component. And then we also do research of regional interest. So within the diagnostic services, for example, last year we cover a broad range of different fish species, from marine fish to freshwater fish to warm water fish down to cold water fish. So we see, all different species that come through the lab. We work with trout hatcheries up in North Carolina, Tennessee, Georgia, South Carolina, from those hatcheries there, as well as everything tilapia, catfish, everything down to the marine coast. We see it all. And so we get all of these cases. So just in this last year, just on our laboratory, on our campus laboratory, we saw a little over 100 cases, which is down actually a little bit. Historically, anywhere between 100 to 350 cases a year just on our main campus lab. We've got another satellite laboratory that we provide a backstop to that serves primarily the catfish industry in West Alabama. But he also sees a lot of sport fish, pond, recreational pond type cases as well. And he typically sees anywhere between 300 to 600 cases a year. So we get a variety of different sources for our fish, anywhere from private pond owners all the way up to government sources, from hatcheries, commercial farms, you pretty well name it. Anywhere, commercial aquaculture, hatcheries, conservation agency hatcheries. We also look at fish diseases from natural habitats as far as kills that may be happening or issues that may be developing in creeks, rivers, lakes, reservoirs, both from freshwater and marine, as well as the recreational pond owner. Oh, and please, stop me if you have a question, okay? I teach class, so I don't mind ask a question if there's something you want to know right up. I'd rather have this to be a discussion instead of me just getting up lecturing like this, okay? So please stop. Also within these diagnostic services, we provide a basic water quality service. So it helps us understand exactly what's happening that is associated with the fish mortalities. Whenever you start getting into some of the more technical aspects about water quality, especially as it relates to pesticide toxicity levels, we farm those out to other specialized laboratories. If it's within our state of Alabama, we go through our Department of Agriculture has a pesticide laboratory, an ag pesticide laboratory. Otherwise, we recommend them out if it's coming from out of state where there may be a pesticide issue, recommend it out to a private laboratory that can then do those testings. We then also have part of our biggest issue that we look at are our infectious disease identifications. We've got capabilities looking at parasites, viruses, bacteria, fungi, and we use a variety of different methods to come up with a diagnosis on all of these, including classical methods. We look at also molecular methods where we're looking at specific strains of DNA that will specifically identify a pathogen down to the strain even. So, and that's part of some of our molecular biologists, and their work is, that's the type of tools that they're developing for very specific identification, as well as doing some pathological or histological methods to understand the cause of pathology, the cause of disease, what it's actually doing in or on to the animal. We also have a lot of what we call certifications going on. And this comes from both the private as well as governmental sources, especially right before fish are stocked out into areas. A lot of these come from federal or state certifications before fish are moved into those areas or out of areas. How many of you have heard of VHS, viral hemorrhagic septicemia? Big problem up in the northwestern area around the Great Lakes region. Well, because of that, there are certain diseases, well, with VHS, the federal government, they mandated that any fish movement outside of that watershed has to be checked before they can be shipped out. And they have to have that fish health certification to show that they're so-called disease-free. Now, when we say disease-free, we can't guarantee 100% that they're absolutely never come into contact with that pathogen before, but at least we know within a statistical probability that they probably are not carrying the virus. And so a lot of states also have different mandates. So, for example, in my home state of Alabama, it's pretty much the wild, wild west. Fish want to come in, you can bring them in. You go down, no reporting necessary. Probably one of the more stringent states that has, as far as requirements for fish showing these pathogen-free status, is like New York. They've got about 30 different pathogens that they want certifications from before fish are moved into that state. So you have to really look at each state's Department of Ag, DNR, Conservation Agency regulations before you're moving fish in. But we can cover all that because we go by, everything that we do in our lab is pretty much by the AFS, or the American Fisheries Society Fish Health Section, what we call the Blue Book methods. And basically this is the gold standard for diagnostic methods that all diagnostic labs around the country are using to be able to come up with diagnosing diseases as well as certifying these pathogen-free statuses. Okay, that's a little bit on our diagnostic services. On the continuing education front, We provide, as far as going directly back to the states that are members within our cooperative agreement, we provide a continuing education for the conservation biologists and technicians, and this can vary from field biologists and technicians all the way down to the hatcheries. We provided lessons and topics of areas that we cover as basic disease principles and concepts, to how to collect and care for samples, which is the biggest problem that we see coming in, not only from governmental agencies, but private pond consultants to farmers, pond owners, because that's where it all lies. If we in the diagnostic lab do not get a good, proper sample that has been taken care of properly, there's a lot of times we just have to call up and say, there's nothing we can do. You need to get us another sample. Because most of the time, if the fish sit in the water more than 2-3 hours, especially in the middle of the summertime, that fish is already beyond what we can do. As well as one of the other big problems that we typically see is people, they have a fish kill or they see fish dying, they collect it, they freeze it immediately. Then they make a phone call. And freezing will actually do more harm than good. So there's things there that we go through, and we try to teach our biologists and technicians that we work with just how to care for these samples. What are the proper samples to collect? What kind of samples are we looking for that we need you to target? What are some of the techniques that we need you to collect on field, on site? Are there certain necropsy techniques that we need you to do actually out on the field, on site? So we do go through that basic necropsy process. And then we cover basic or common pathogens and their characteristics, and then look at, associated with that, management techniques and treatment strategies and how to implement those things. So some of our research of regional interest that we're focusing in on, based on the topics that I gave you as far as the people that are involved in our laboratory and the program, you see it's pretty varied. And so we cover anything from freshwater to marine interest, and it's anywhere from basic laboratory techniques like molecular DNA type identification, development tools, to the applied field-based arena. Some of the topics of general interest include genetic considerations, both not only for the fish, but also for the pathogen itself. Because as I said, there's a lot of different strains of pathogens that will cause a variety of different kills that may take on different flavors as you would. As well as some of the fish themselves. What are those genetic characteristics about certain lines of fish? Are they susceptible to certain pathogens and more resistant to others? And that's part of Dr. Peatman's research interest, is looking at some of those specifics. What are the pathogen characteristics themselves as far as how do they cause disease? Do they produce toxins? Do they produce enzymes? What is their life cycle like? All of those are part of our research interest. What is the pathology? What do they actually do to the fish itself? As well as that kind of transitions into the lab, into my area of epidemiology. What is the prevalence of these certain pathogens, and how do they interact with other issues that are happening within the system? As we've kind of already seen this morning with water quality issues, nutritional status, I work with a whole gamut of people. And so when we take and we try to understand and do the research with diseases, especially from an applied standpoint, we have to look at all of these different factors and what is the symbiotic type process, what is the interaction of all these things together that causes ultimately the death of the animal or impedes its fish health aspects. So we're constantly working with nutritionists, we work with water quality experts, we work with fish husbandry individuals, geneticists, you name it. So it's a real multidisciplinary approach to overall fish health management, as well as the spread of different pathogens. What are those life cycles like? And then one of the other area that I'm directly involved in is the treatment, control of, and preventive strategies. And this would include not only how do you manage the ponds or how do you manage a fish population to sustain the best growth possible, but what kind of therapeutics can we come up with? Is it just antibiotics? No. It's other things that we can do. The mention a while ago of probiotics in the nutrition talk. Well, we're also looking at some of these probiotics because some of them actually start producing some compounds that will kill pathogens, and they're very selective about killing fish pathogens. So how can we use that to help control fish disease issues, especially in hatchery and commercial aquaculture settings? But then we also look at preventive strategies, especially involved in vaccines. So our work is involved in not only in developing vaccines, looking at the pathogen characteristics that we can focus in on in helping to develop a vaccine, but then also taking even commercially available vaccines and doing field efficacy tests to see whether or not they really are cost effective. Because in the end, that's what it all boils down to, especially with control, preventive strategies, and treatment, is what is the best way to control cost. And that is our bottom line. We've got an economist on staff, and he will help us as far as putting dollar figures to these strategies to help us say, well, it's effective, but it's not good enough because it's going to cost too much. Or helping drug companies or vaccine companies saying, here's what you've got to introduce these costs in at, because this is what people are going to buy it at, as far as for helping with marketing strategies. So that's basically a very broad overview. I didn't get into real specifics as far as our research projects. Just a couple of mentions about emerging disease issues. We do try to follow the federal guidelines and things that are happening around the country. Stay involved with other labs, federal agencies to keep on top of issues that are arising to help at least get this back out to stakeholders. And not only with, staying within our pinhead academic arena, but trying to get it back out to the stakeholders. People like yourselves that are working with pond owners, or you're a pond owner yourself. How can you implement some of these strategies? What is the newest information available to help control disease issues? And we're not talking about just infectious diseases, but also non-infectious diseases. And I'll be covering a little bit more about that tomorrow, especially some of the issues that are on the horizon. But with that, I'll entertain any questions that anybody has. Before I start doing that, I've got my contact information up here. I'm more than willing to, if you want to call me, bounce ideas off of me, send samples to our lab. We can discuss all that. But what kind of questions can I entertain? Yes.
I just want to make a correction that something you said, that the Great Lakes are not in the Northwest.
I'm sorry, I did. Yeah, Midwest. I'm sorry about that. Excuse me. Yes.
The thing I wanted to ask about is that when the VHS ruling came down with the interim rule enforced by the feds, states had the ability to trump that ruling and make it more difficult. And what happened with some of the fish farmers is that they didn't know what rules they had to abide by. And so my question to you is Auburn or anyone that is a stakeholder within a university trying to get states to work together to have those rules all be the same?
Yeah, actually right now where the VHS ruling stands is we're in an intermediate ruling period. They had the initial rule that come down, then they went to public comment to gather all those concerns, and they come down with this intermediate rule. And they have not come down with a final ruling yet. They are working with stakeholders to find out what all the ins and outs of that specific rule is going to be. And everything's kind of been quiet. Everything's been put on a standstill for the last about 3-4 years now. And we're not sure exactly what to do. Most of it is still on the state level with, like you said, the state levels are pretty much trumping what the feds are saying. But until there's more research, I think, is what they're probably trying to gather and what the overall economic impacts are going to be, because it not only is going to affect recreational ponds, but we're real concerned within the commercial aquaculture industry how this is going to affect those industries as a whole. And there's a lot of money at stake within that. And so I think that's where they're at right now. But yes, everything is pretty much being gathered through stakeholders as well as on university governmental agency level from the American Fisheries Society, where most of the collaborators are coming in and voicing opinions as well as with the stakeholders. Does that answer your question?
Kind of.
Kind of.
Well, just states working together would make things easier, but you have to wait until you get the interim rule.
The final rule is probably right now the biggest key in that, is because nobody knows what the USDA, what the feds are going to say about it as far as the final rules. And I don't know how different states. I think that's going to be what it's going to boil down to is the final rule, and then the states are pretty much going to develop the rules around that. But how states are going to work together. I mean, I was at a meeting this week. I was at a meeting this week with the fish chiefs from the southeastern region. There were 13 of them in the room. They couldn't even decide on where some of the future meetings are going to be taking place. What they're trying to do, they're trying to get their meeting scheduled in with the Southern Division of the AFS meeting. They can't even decide if they want to do that or have their own meetings. So much less when it starts coming down to these political issues like this, I don't know where it's going to go. I have no idea. Yeah.
Have you been testing any private ponds and lakes for LMBV?
Oh, yeah.
So what have the results been? Is it still making its way across the country?
Well, I'll tell you what, I have not seen as far as, I'm glad you brought that up, is one of the things that we've been seeing with LMBV is we haven't seen any real geographic spread outside of the main Mississippi River drainage area. There's kind of that little pocket up in the northeast New York area. But I'll tell you what I have been seeing coming through the diagnostic lab. And it's been a transition or a change where LMBV cases that were sent in, and we do check largemouth bass whenever they do come in. That's one of the first things that we do is outside the general, or as part of the general necropsy, is we take samples and run them for LMBV, at least looking at infection. We are not seeing many cases coming in from the large reservoirs like what the first initial impacts, what really got it on everybody's radar screen. But where I have really seen a transition in the last couple of years is it migrating down into the recreational ponds. I've seen more and more cases coming in anywhere between a 20 to 50 acre pond. And it's somebody's own managed pond. And I think a lot of it has to do with, some biosecurity issues where people are going out fishing, they catch a nice trophy fish, and they say, this would look really great, probably provide some good genetics into my pond or into my buddy's pond. They put it in the live well, they take it home with them and drop it in. And the things with LMBV is a lot of the fighting, the angling, the stress associated with that will actually induce the virus to come out. And that's probably part of it. So we've got carrier fish out there that anglers are catching these fish from and probably stocking them into areas where they shouldn't be stocking, as well as, probably not doing good disinfection of boat, equipment, stuff like that whenever they go from lake to lake, pond to pond.
Follow-up question.
Yeah.
When I was researching LMBV years ago when I was at Auburn, there was some folks speculating that LMBV could be introduced via birds, avian transport. Are you seeing any of that, or has any more been researched on that?
No more has been researched on that I'm aware of. They really haven't, the research in this area really hasn't even detailed what other carrier fish could potentially be harbingers of this virus. What are the bluegill, the shellcracker? Are they real carriers, and how much of an impact do they have in the introduction of it? I don't think a lot of that has really been worked out that well. And so trying to transition over into the birds, I don't think the research is not there, so I can't really comment specifically on that, but nobody else has really done the research on that, of how long that virus would last in a dead carcass, and especially as it starts going through, the fish's intestine and them being able to go from pond to pond or defecate, or even on the feathers or, on the wet feathers or the body of the animal.
One last follow-up question on the same topic. In the reservoirs, mainly LMBV was more acutely associated with larger individuals, the bigger fish, the trophy-sized fish. Are you seeing the same with the fish you guys are testing?
Yeah. As far as our diagnostics, what we're generally seeing is 4 or 5 pounds up. And it takes on the classical pattern. Hot time of the year, bigger, larger fish. And you initially see them up on the top of the pond struggling. And, and this past year we started seeing cases 1st of June, because we had such an early summer. We had a real hot period, and we were seeing much earlier cases than what we generally see.
Jeff, can I follow up on some of that?
Yes.
Jeff, I guess. A couple of things. One of the bird thing, I've thought about that too, and all the cases I've seen from smaller ponds have been in ponds that are large enough that people put boats in. You would think if birds were moving them around, we'd be seeing cases out of 2-acre and 3-acre ponds, and we haven't seen any, so if it happens, I don't think it's a big problem. But we had a lake, it was a 75-acre lake that had an LMB virus kill a few years ago, and people get so worried that it's going to wipe out their big fish population. So we actually were lucky enough to do a population estimate in that lake right before the kill happened and right after the kill happened. And even though it killed a fair number of the bigger fish, it only took out about 7% of the biomass in the population. And especially in the south, it doesn't take long for a large enough bass population to rebound from that. What we find is, it may restructure the population for a couple of years, but in reality, we only saw the biomass of that lake dropped to about 70 kilograms of bass per hectare, which is about 70 pounds per acre roughly, a little bit more, which is about the maximum carrying capacity of most ponds anyway. So it really didn't drop down very much at all. So I think it's a one-time impact, and once that virus gets into the population, it seems like the remaining fish are not immune, but they're carriers. But
well, they do have those carriers, and they will start shedding out probably low levels of the virus that other fish are picking up, and they're developing probably an immune response to it that transitions, just like we get immunized for different viral pathogens. That down the road they may or may not develop the disease, but it's because they've come in contact with low enough levels where it doesn't kill them, but it also induces a strong enough immune response that they can overcome it.
Exactly. So you don't usually see the one-time kill, and you don't see it after that unless maybe you come in and stock a bunch of naive fish, and then you might have that problem again. So.
Yes.
Where does one go in the U.S. for a forensic pathology capability? Would that be something your group might work on?
Depends on how forensic you want to get. Most of your fish disease labs we're not the CSIs. It's very difficult to do something like that. We try any kind of disease case that we're looking at. We do take into account history, because it's a lot of the things that happen, before the mortalities ensue. What happens to the fish then that sets them up for it. And so trying to step back in time like that is typically associated with diagnostic labs, but that can be very difficult. Yes.
I just
comment.
Yeah, this is just a comment. The worst thing for us as managers and biologists is CSI, because they come up with the solution in an hour.
Yeah.
Right? I mean, it takes us a lot longer to figure out exactly what happened.
Yeah. It's very difficult. It takes usually a team of people, that's much broader than just any one group has. It often takes people from multiple institutions, governmental agencies, to be able to come up with some of this. Like, for instance, the VHS issue. I mean, it took a while to be able to figure out exactly where that virus, how it gained entry into the Great Lakes system. But they were able to go back and kind of track that. But it took a large team of people to be able to do that.
Jeff, I would say too, like in the case you studied for us in South Carolina, I mean, we got you the fish too late. I mean, we all think it's largemouth bass virus, but we waited 6 months till we're down to electrofishing work, and then we couldn't pinpoint it. So not only doing CSI, but just doing any diagnosis as quick as you can get the fish.
The wrong time of the year of submitting samples can be just as unrevealing as not submitting any samples at all. Yes.
So how are you compensated? How do we pay you? How does it work from a fee structure standpoint? And then if we have an issue, what do you need from us in terms of sampling? How many fish do we need to send you? And go over how all that works.
We do have a fee structure set up depending on what it is, like from private pond individuals. It depends on the level, how much work we have to put into it. Typically, top cost would be about $500 per case. That would be everything included. And that's, most of the times the cases are somewhere around $100 to $200. And as far as that, you contact us at our lab to be able to set up exactly what needs to be done. As far as the number of fish, in a general infectious disease process, 5 to 10 fish is more than sufficient as far as that's concerned, as well as some water samples. If you can find that number of fish that are all showing the very same clinical signs, same general behaviors, abnormal behaviors, then we can generally come up with, you know, an idea on most of that.
It's dry ice overnight shipping?
No, actually dry ice is not good because it will actually freeze the samples. And so typically what we're looking for are samples that are collected alive, and then take them, immediately get them out of contact of water. Put them, seal them up in a garbage bag, a paper bag or something, but we want to get them out of direct contact with water. Pack ice around the sample, so we've got a sealed fish sample. We want it fresh, and then we want to take ice packs, and preferably ice, these these ice packets, or taking sealable bags and putting ice in that and then packing it around the fish. We want the fish refrigerated and chilled, not frozen. Unless it's going to be, you're collecting a sample on a Friday night and you can't get it shipped out to the next Wednesday or so, you really need to make contact with the diagnostician and talk about the issue first. But don't immediately freeze it. Keep it fresh as long as possible until you can get a hold of the diagnostician, and then to be able to talk about your options and exactly what the goals of the diagnosis, or what the diagnosis is. When we're looking at infectious disease kills, that kind of number is more than sufficient. If we're going to find anything, we're going to find it within that time frame or within those number samples. If we're looking at like disease certifications, where we're just looking for how a pathogen is maybe distributed within a population, or in the case of like the VHS, before we have this certification process of disease-free status, then typically it's anywhere between 30 to 150 fish. Depends on what exactly we're looking for and what specific tests need to be done.